And as you know, as always, we want to do a membership spotlight at the beginning of our sessions. And this is not one, but two members, a 2-for-1. Our member, Sean, has been hired as the construction project manager at our members' Habitat for Humanity, Kent County. Sean is studying for his Certified Green Home Professional designation and LEED AP Homes, which will help as Habitat is 100% committed to LEED certification standards for new construction, exploring and starting to do electrification heat pump projects, and also getting into embodied carbon reductions. So a huge congratulations to our member, Sean. You know, this is who Green Home Institute members are. This is what Green Home Institute members do. So can you go to our website and learn more on how to become a member and the benefits. All right, well, welcome everyone to Heat Pumps Can Be the Next AC, Air Conditioning, a Study. Before we get into the session, I want to say a huge thanks to our top tier sponsors, Mitsubishi Platinum level sponsors. And I want to say I am celebrating 3 years this month of having my air source heat pump, ducted air source heat pump Mitsubishi system, Hyperheat, installed in my house, going all electric and staying super cozy, super warm. It works great. And, you know, I understand that going all electric and going fully air source heat pump is not going to be available for everybody, and we get that. And so we're going to talk a little bit today, especially about other options you can have to sort of get halfway or more than halfway there. And so it's super excited to them, and stick around. We're going to talk a little bit more about that option or going fully electric. And then also we need to stay healthy, and I'm staying healthy by monitoring my air quality with Sun Radon. One of our sponsors. Again, I'm monitoring my radon to make sure it stays low, VOCs, temperature, humidity, air pressure, even takes a mold kind of risk reading down in the lower levels, taking a look at dew point risk. So real great product out there, works for single family, and they've got a multi-family version and a home inspector version. So check out Sun Radon. All right, well, welcome to, again, Heat Pumps Can Be the Next AC, a Study. This session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We are a small but mighty team. My name is Brett Little, and I'm our education manager, and I will be your moderator here today. As with all of our sessions, this one is approved for multiple continuing education units, including our Certified Green Home Professional designation under the Health and Energy pillars. AIA, Health, Welfare, and Safety, may make it applicable to your state-based design or contractor license. And check out the Passive House code at the end when you've completed this session for your FIAS CPHC use. So very exciting to be talking about this topic. We've been talking about heat pumps. We've talked about dual fuel opportunities in the past. But I'm super excited to have our speakers on today, going over a little study and then real world applications of someone who installed one of these. So Samantha Hill with CEE and Kevin DeMaster with Mitsubishi, welcome. And Samantha, please take it away and introduce yourselves. Thank you.
Thanks for having us on. My name's Samantha Hill. You can also call me Sam. I'm a research engineer at the Center for Energy and Environment. We're a nonprofit based in Minnesota, focusing on all things energy efficiency. And I'm happy to be here today also with Kevin DeMaster, who can provide a quick introduction to himself. If he can jump off of mute.
Oh, good morning, good afternoon, everyone. Kevin DeMaster with Mitsubishi Electric. I'm our Senior Manager of Utilities and Electrification. I'm based in Wisconsin, but we have our corporate offices out of Atlanta, Georgia, and happy to be on this panel today. Thanks.
Awesome. Well, we'll get straight to the chase. Today, we're talking about how heat pumps can be the next air conditioner. And our agenda is pretty tight. We're going to talk about heat pump basics and specifically what kinds of heat pumps we're focused on for AC replacements. I have some exciting field study results to share that look at a population of these kinds of systems being installed in Illinois. And we'll also have feedback directly from homeowners for our project, and also with Kevin, who has experience with these kinds of systems on his own home. We'll start at the very broadest picture. We're interested in heat pumps for AC replacements because space conditioning consumes a lot of energy in US homes. And everybody, there's growing consensus that decarbonization of space heating by electrification is really a key strategy for mitigating climate change and improving the efficiency of our buildings. However, it's definitely a challenge to convert all buildings to all electric heating systems. It can still be prohibitively expensive to install equipment that has those capabilities, and it can be more expensive for some homes to operate all electric. And so we have to work out solutions for people who in homes that aren't great candidates right now yet for all electric heating systems. So that's kind of the inspiration for looking at heat pumps for AC replacements. Let's start where we can for homes where the leap to all electric is a bigger jump. So the question we're going to be focusing on today is really looking at what impact can heat pumps have when they're installed as central air conditioning replacements. If you're not familiar with heat pumps, here's just the broad overview. The key thing you need to know about a heat pump is that a heat pump doesn't generate energy or generate heat. It just moves it. So it can move heat out in air conditioning mode, or it can move heat in heating mode. So you can think of a heat pump as a normal water pump, but for heat. And the really exciting thing about heat pumps, because they're moving heat and not generating it, they can be exceptionally efficient. And so they're described by what's called the coefficient of performance, which just quantifies how much heat they're able to move for how much energy it costs to move that heat. And heat pumps are delivering COPs typically between 1 and 5. That's equal to an efficiency of 100% to 500%. And these factors are all depending on the specific heat pump model and the location and temperatures where they're operating. So this is a really efficient technology, and there's a lot of different types of heat pumps out there for a lot of different kinds of applications. Here's some pictures of residential type heat pumps. The list of different kinds of heat pumps that are out there is long, and new heat pumps and new applications are being explored continuously. But we're specifically looking at one subtype of heat pumps today, and I'm going to call them coil-only centrally ducted air source heat pumps. So that's the heat pump of today's focus. What they look like is really what a traditional air conditioner and furnace system looks like. That's pictured here on the left. We're specifically talking about dual fuel applications where the heat pump is replacing the air conditioner, many of you are likely familiar with, and retaining a centrally ducted furnace in the home. And the systems work together to provide heating and cooling. So this is a direct analog to an air conditioner and furnace combo. We're just talking a heat pump and furnace combo now. Traditionally, most air source heat pumps for residential applications have required a simultaneous replacement of the air conditioner and furnace at the same time so that those two components can work together seamlessly. This has been in part to improve performance of the overall system, and it's also in part due to limitations that we have in terms of how these kinds of products are rated and assumptions that are made about the whole system when you're replacing just pieces of it don't really fit perfectly into our existing rating systems that help us compare an efficient system to another system with different performance specs. And so that's historically how heat pumps have been installed in residential applications. But today, there's a growing number of products out there that we call coil-only heat pumps, meaning that they are only paired with a coil that attaches to your furnace, same as an air conditioner, and they can be installed on any air handler or any existing furnace, as long as you pick the right sizes to match up. And so these systems have new control strategies to make sure that they still work together and can provide heating with the heat pump when that makes sense and heating with the furnace when that makes sense. And so they're a little bit more of an advanced iteration on air source heat pumps that you may have already been familiar with. The key change is that they are able to install on pre-existing furnaces, and that is a great opportunity for us to reduce the installation cost of air source heat pumps for homeowners who can't replace their entire HVAC system all at once. If they're already replacing an air conditioner, this could be a great opportunity to make the upgrade to a heat pump without seeing exorbitantly high incremental costs for making that change. So that's kind of just a primer on what we're talking about today. I'm going to hand it over back to Kevin now, who's going to talk a little bit more about a specific system because he has experience actually installing these systems or this kind of system or kind of technology on his own home. Kevin, we can see your screen and now we can hear you. Perfect.
All right. Thanks everyone. Sorry, just, working with different technology platforms, a little bit of a challenge here, but well, great to be on this call today. And I just love the context that Sam, laid the foundation of some research that was conducted and where the market is really, changing in terms of products that are innovating to meet consumers' needs at various application points. So, my goal is to kind of set a little framework here about when homeowners are faced with that decision about an AC replacement or, for the matter, even a new construction, and they want to go with a dual fuel strategy, I'm really here to just kind of lay out a little bit of a context about what these retrofits or applications with dual fuel systems can look like. But first, I wanted to talk about the heat pumps. We talk about heat pumps, and even though we are a manufacturer, heat pumps come in different shapes and sizes and forms, kind of as Sam had outlined, right? And so the context of our conversation today is to talk about that centrally ducted system with a cased coil type arrangement. When you look at traditional, heat pump technologies, there are different types that I just want to make everybody aware of. You have conventional systems that the compressor might be single speed or dual speed, and it might cycle on and off and not have as much variation or control with the type of compressor. And so what a homeowner may experience is fluctuations in temperature as the system cycles in an on or off state. When you talk about technologies that have variable speed systems, otherwise, referred to as inverter compressors, these are more advanced technologies that have entered into the market across many brands. And the benefit of that type of compressor is it allows more precision comfort control and usually translate into a much better homeowner comfort experience. But another benefit is that there's reduced energy consumption. Once it finds its temperature, it's able to just modulate and maintain the minimal amount of energy necessary to maintain comfort. And that is where Sam kind of alluded to the whole COP concept. Kind of build a little bit on this market that Sam talked about is when you look at the US as a whole, 52% of the residential heating market uses natural gas as its means of heating. And, there's roughly 60 million gas furnaces that exist across the continental US. And about 90% of these gas furnaces are traditionally paired with an air conditioner. That might be a cooling only coil, otherwise referred to as central AC. And so that is what most, the most configurations look like today. And so when looking at a product that is a dual fuel system or a cased coil that allows integration with existing furnaces, there's some things that people might benefit by going with a dual fuel system at an AC replacement. Number one, you get to extend your shoulder season, and which effectively gives you a much higher COP than just going with that gas furnace efficiency, especially in the shoulder seasons. There's a lot of potential for heating cost savings, both on the cooling and heating, because that coil becomes both a heating and cooling solution. If homeowners are interested in reduced fossil fuel usage, this is a great strategy to reduce those carbon emissions. And, another thing that I think is, as the grid, or, just as a country, we begin this journey of electrification, managing our grid and sustainability of that grid transition, makes sense when you can put the right type of heat pump on the grid. That might be dual fuel, might be variable speed compressor, but you can see there's different strategies that make this transition a lot cleaner. What you're really starting to see is a trend. Utilities with their energy efficiency programs for some time now have been walking away from, or moving away from, just an essential AC rebate, moving more towards a heat pump solution, which could include a retrofit to a dual fuel solution. And so in a bit here, I'm going to talk a little bit about my journey and my experience and how I made my choice. The choice I made for the product and the case coil I put on my furnace was that it had the flexibility for anywhere from a single stage furnace to all the way to variable speed furnaces. And so that was appealing to me as a homeowner, as I live in Wisconsin and in a northern climate, that heat pump technology is getting kind of stretched to its performance. So, that's something that was important to me. So the choices I had was to stick with my existing structure, which is take an outdoor unit with a cased coil, apply it to a furnace in a single zone application. But my home had some comfort issues. In fact, the office which I'm coming to you from today, is one of the areas which I had comfort issues. It's on a second floor, and it's the only room up, and so I needed a different type of configuration. And so part of my product choice was the fact that I had flexibility to choose the type of configuration I wanted with this cased coil configuration. So that was really important to me, and I'm going to talk a little bit more about that here shortly. But as you're thinking about a dual fuel application, you have to really understand a few things, right? You need to understand what is the design load of your existing home when making a choice. You need to know, which is represented by the yellow line here. The brown arrow at 5 degrees, you need to understand what your design temperature is that you're designing to. So really doing load calculations is critically important in any HVAC application. But you also need to understand your equipment and the capacity of it. And so the blue line here represents maybe a traditional heat pump configuration. And so you can see where the two lines intersect is what I call my balance point, and where the heat pump is capable of meeting the need at various outdoor temperatures. And so there's obviously this gap here. We've got a gap to make up as the weather gets colder and the load is greater on the home. So that is where a dual fuel or a backup alternative solution needs to take effect in a consumer's decision. Now, when you look at the type of heat pump, I showed you maybe a traditional heat pump. And if I go back here, you can see kind of how much in that orange triangle had to be made up by a secondary source. Now, when you choose different types of heat pumps, they're going to give you different performances. I chose an all climate heat pump, something that was designed for much more cold weather performance. And so what that does is when you introduce a technology that some people might call a cold climate heat pump, you know, you extend the capacity of that type of system much further into cold weather temperatures. And so when I match that up against the existing home load we described earlier, I end up with a capacity balance point that is much smaller if my desire is to have the heat pump be my primary load. And so I was able to push that secondary backup much further down to colder temperatures in this scenario if you're looking at an all climate heat pump strategy. And so with that said, I'm going to hand it back over to Samantha to carry it forward from here.
Thanks, Kevin. So Kevin gave us a lot of great detail on considerations he made for choosing a system. But overall, I wanted to highlight just that the market is ready now. There are multiple products out there that are ready for AC replacements and have configurations that work in coil-only installs, including products that have cold climate capabilities. So these new products are really the reason why AC replacements are being of higher interest now. And that's due to the new control strategies that are being used for these systems. On top of that, federal and utility rebates are starting to pay attention to this product category. And so there are an increasing number of rebates available out there for homeowners interested in this technology. And overall, the benefits that heat pumps can provide over ACs can provide cost savings for customers. And, you know, we're kind of reaching over the hump of this brand new technology is untested. There are increasingly people out there who are aware of these systems and can help homeowners make the leap from AC to heat pumps. And in fact, I wanted to share with you today some results of a field study that we performed in Northern Illinois through a project that's been funded by ComEd's Emerging Technology Program. This was a field study that actually evaluated the performance of more than 30 variable speed heat pump systems installed in ComEd's territory. And it also included 3 single speed heat pumps for comparison. All of these systems were installed as dual fuel applications, so they were centrally ducted heat pumps installed on existing furnaces for dual fuel operations. So they provided air conditioning, some heating, and then they had supplemental heat for the coldest conditions in Illinois. We gathered continuous operational and performance data from these 33 systems for about half a year, from late 2020 or 2022 to this past summer. We also surveyed participating homeowners about their experiences to learn what having a heat pump as an AC replacement is like, and to learn about the comfort factors that Kevin has mentioned. So overall, we learned a lot about this product category, and we learned exactly how they are different from AC replacements. So how is a heat pump that you might install just in the hole that your AC forms if you were to replace it, how is it different? There's really only 3 major differences between a heat pump and an air conditioner based on our study. First of all, the biggest difference is that heat pumps can operate in winter and summer. So the siting location of your pre-existing air conditioner might not be perfect for a heat pump. And heat pumps usually need to be installed on snow stands if they're in a snowy, cold climate location. So this difference may vary depending on where the heat pump is installed, and is pretty important if you live in a very cold climate. In many cases, you can install a heat pump in the exact same spot where an air conditioner was. You just want to be aware of the snow conditions and make sure that it doesn't get covered entirely by a pile of snow over the winter. The other big difference is that you might need to upgrade your thermostat if you want to upgrade your air conditioner to a heat pump. I'll talk about that more in a second. And then sizing is also very important, which might not be paid as close attention to in an AC style replacement. Sizing a heat pump can be informed by a lot of factors depending on what your priorities are. If you want excellent dehumidification, or if you want to electrify your heating as much as possible, you might make a different sizing choice for your heat pump compared to an air conditioner. So first, talking about that thermostat difference. I've gone too far. Thermostat selection is a critical difference for heat pumps installed as air conditioning systems, especially for homeowners who want to use dual fuel operation. And that's because not all thermostats out there can control a heat pump. And a lot of these heat pumps that are available for coil-only installations on pre-existing furnaces are compatible with third-party thermostats. As a general rule, and manufacturers don't necessarily require a particular thermostat to be installed to make the system work. So homeowners have the option to choose from a variety of thermostats. It's important that they choose a thermostat that will actually unlock the full potential of their system. And so these thermostats that are installed with these systems should be for sure have the ability to control a heat pump, and then they also need to have controls that allow dual fuel operation. Dual fuel operation has a few requirements for a thermostat. These are the key features to look for when choosing a thermostat for a heat pump replacement. I won't go into a ton of detail here, but what's really important is just having the ability for the thermostat to determine whether the heat pump should be in heating mode or cooling mode, and whether or not the heat pump should run or the furnace should run in cold weather. So in order to do that, it needs to have extra wires. If your home already has a wired thermostat and there aren't enough wires in place, there are wireless thermostat options out there. The dual fuel control software is really important. That's kind of where you program in exactly where you'd want switchover to happen. It's related to all those figures that Kevin has already shown about when the heat pump should run versus the furnace. And those numbers could be adjusted depending on the economics of your gas versus electric bills, or if you have propane, or just based on comfort preferences. And so a key requirement for usually making that decision by the thermostat is having an outdoor air temperature monitor. And so there are thermostats out there that have local air temperature monitors that can be installed, but there are also a lot of thermostats out there that don't need this extra sensor and just use local weather data from a Wi-Fi connection. So extra wiring isn't necessarily required in order to have that functionality. It's also nice to have multiple stage heating controls. That just gives you a lot more options to exactly how the systems interact in heating mode, but that is an optional feature. So besides thermostats and where exactly you put your heat pump, the last big difference I mentioned was sizing. So sizing is really important for HVAC systems because if your system is too small, you might not be able to keep your house warm or cold enough to maintain comfort. And if your system is too big, you may have issues with that oscillating, switching on and off, similar to what Kevin was discussing about single stage systems versus variables or multi-stage systems. And I guess pulling us back to the field study that we did in Illinois, we found that sizing was really important. But we found some surprising results when looking at a population of systems for AC replacements. All of the systems in our study were sized for cooling, in the sense that the contractors generally took a look at what size air conditioner was there and selected the closest sized heat pump that they could get to that system. So the heat pumps were sized very similarly to pre-existing air conditioners. However, what we found after our monitoring was that the existing HVAC equipment at the majority of the sites that we studied were vastly oversized compared to their actual heating and cooling loads. This plot is showing the ratio of the actual capacity of the systems divided by the design heat load. So a ratio of 2 means the system has twice the capacity as it would need at design conditions. And a ratio of 5 would say it's 5 times as big as it necessarily needs to be. A little oversizing is beneficial often because having a little bit extra capacity improves the responsivity of a system. But systems that are 5 times bigger than they need to be actually have poorer performance. They short cycle, they turn on and off a lot, so they have a hard time maintaining consistent set points, and they may have lower equipment lives due to this rapid cycling all of the time. The impact this has on AC replacements is that a heat pump that's installed as an AC replacement on a generally oversized system is going to have a surprising amount of heating capacity in cold climates compared to what might be expected for a right-sized system. So right-sized systems, the air conditioning loads may not always equal the heating loads. That's especially true in northern climates where cooling loads are much smaller. And so an air conditioner wouldn't have the capacity to heat a lot into the winter if the system's actually sized for the cooling load. However, we're finding it's pretty common for systems to be oversized, and that gives us a lot more room to play with for heating, which is a sort of happy accident for many homeowners. Here's a bunch of data from all of the sites that we were monitoring in Illinois, showing how much output we were able to measure from the heat pumps as compared to that home's actual heating load as a function of temperature. And so when the output the heat pump can provide is equal to the home load, that's what's known as the capacity switchover point. That's where the heat pump at colder temperatures won't be able to keep up and heat the home to that set point. Above that point, the heat pump has enough capacity and can potentially provide all of the heating needs at temperatures warmer than that. And since the systems that we were studying were so oversized in general, on average, many systems were able to heat the homes to temperatures of 30 degrees or less. In fact, some systems were so oversized that the air conditioner or the heat pump that we installed had the capacity to essentially cover all heating loads down to the lockout or lower temperature limit of that particular heat pump model. And so this has huge implications in terms of what the size of the opportunity is for AC replacements. It could be much bigger than people expected for heat pumps replacing air conditioners in cold climates. We also measured the efficiency of the system. So I mentioned early at the start of the webinar, heat pumps are rated based on their coefficient of performance, which is a description of how much heat you get out for how much energy you put in. This plot shows the coefficient of performance we measure at each site, and the red lines are the averages performance of all sites in the population. Overall, these results are pretty similar to field results studied in the Midwest for brand-matched variable speed heat pumps. So that's very promising. It's very interesting that based on our results, the HSPF, or the heating season performance factor, which is the standard rating methodology the industry usually uses to compare the performance of one product to another, the HSPF ratings were not a good predictor of performance for our systems. And this is, again, getting to the fact that our rating structures and systems are not always perfect at describing these systems. And for coil-only heat pumps in particular, which don't define what furnace is paired with it, the rating structure currently assumes the worst possible air handler and fan is paired with the system. So that sort of suppresses the estimate of the efficiency for these kinds of systems due to the fact that the rating system can't predict exactly what furnace is going to be paired with it. And it turns out that it's just currently not an excellent predictor of performance for this subcategory of heat pumps. In fact, most anything we could use or looked at in terms of an indicator performance wasn't very predictive of the performance of these systems. And the best predictor was the ratio of how big that heat pump was compared to its actual heating load. The better matched those two numbers were, in general, we saw better performance. And so this is related to that sizing question. Oftentimes when installers or homeowners replace air conditioning equipment, they say, oh, well, this size worked before, we'll put that same size in. But that doesn't necessarily mean that it's still the right size. As homes have undergone efficiency upgrades and weatherization, the amount of load that the home has can drastically change compared to whenever that equipment was installed. And so it is worthwhile to do a review of load calculations that are pretty typical in sizing HVAC systems, even in replacement applications. So that's an overview on how these systems sort of worked in our field study. Now I have some information about how the homeowners who participated felt about their new heat pump systems. And the short and sweet of it is overall, everyone was pretty positive about their heat pump installation experience. So no participants reported overall dissatisfaction from their heat pump, and more than half of participants were very satisfied with their heat pump as an AC replacement installation. Almost everyone said that they would recommend a heat pump as an AC replacement option to other homeowners in Illinois. The only person who said no said that they just didn't see a big difference to recommend it, meaning that in my mind, heat pumps are a really good option for an AC replacement application because they're as good or better based on this feedback from homeowners. We also asked homeowners why they would recommend a heat pump for replacement. And the things that really shone through in their responses was that they viewed it as an opportunity for cost savings on their utility bills or energy savings on their heating and cooling system. Also really important to homeowners was comfort. 11 of our 33 respondents mentioned comfort as a reason why they would recommend a heat pump. They thought that the heat pump was more comfortable than their old air conditioning system was. And a lot also mentioned that the systems were quieter. So most of the systems in our study were variable speed systems. Those are known to operate much more quietly than single stage systems. And that really was something that homeowners did actually notice unprompted as a benefit to their variable speed heat pump system. We also asked homeowners if they thought that their system was, or how their comfort had changed since their system was installed. And most participants said that their system or their home was more comfortable with the heat pump. The main reasons most often cited were consistent temperatures. These variable speed systems do a great job of holding very consistent temperatures. And it's probably very noticeable for these homeowners who had such oversized heating systems that their system doesn't need to turn on and off all the time if they have a variable speed heat pump that can sort of adjust to the actual load of the home instead of oscillating on and off and maintain a more consistent set point. Another big benefit that was mentioned was better cooling. So a lot of these homeowners, they were replacing their air conditioner because it was at end of life or they were dissatisfied with its performance. Installing a new heat pump in its place improved the performance and yielded better cooling for them, which is consistent with our understanding that a heat pump's exactly like an air conditioner. It just offers these additional heating benefits. And so a new air conditioner or a new heat pump, either way, the feedback is that you can get better cooling with a AC replacement. There were a couple of homeowners who did say that they had a little bit reduced comfort from their heat pump installation. Only 3 respondents out of our pool of 33 homeowners said that they felt a little less comfortable. The reasons why they said they were less comfortable, 2 out of 3 cases was related to how they liked the feeling of gas heating. They felt that gas heating was cozier or it felt toasty warm to have gas heat. And one homeowner said that things were a little bit more humid in the summer. Humidity control is something that air conditioners and heat pumps can do and is best done by either system when the system's sized appropriately for the cooling load. And so it's unclear to us if the reason they had more humidity in the summer was because of the heat pump or because they had oversized systems to begin with, and humidity is difficult to control when your system is oversized for cooling. For homeowners who do like that toasty warm feeling that a natural gas furnace provides, the fact that you can adjust these systems, how much you want them to heat versus how much you want the gas furnace to heat, there are tools available for homeowners who want that kind of feeling to adjust how their system performs if that's really important to them. And in fact, a lot of homeowners actually reported that they did have to adjust how they used their thermostat once they had a heat pump. More than half of our participants said that they did change how their thermostat was used since the heat pump was installed. A lot of the responses or explanations on how they changed it was related to set points. People had this new heat pump and they maybe adjusted set points down or up depending on what was comfortable for them. So it seems that there are notable differences in the comfort and temperatures that the heat pump provides, and that a simple adjustment of the set points of the thermostat can be a good way to tune things in perfectly to everyone's preference in terms of the occupants in the home. We also had a couple mention they actually reduced setbacks. So a setback is when you have your thermostat on a schedule and maybe you set it to really cold at night when you like it to be cooler, or you set it colder during the day as an effort to save energy. And for heat pumps, they are generally not drastically oversized to the actual heating load like furnaces are. And so they can sometimes struggle to get back to temperature if there has been a deep setback. And so a couple of homeowners maybe noticed that, and they reduced how much they have their setback, but still felt that the systems were working well with that change in the program. A lot of homeowners also mentioned that they did make adjustments to when the furnace runs versus the heat pump runs. And this is probably something that is unique to every homeowner or occupant on what their preferences are. So anyone who wants their furnace to run more can make adjustments in their thermostat to make them run more. Or if they want their heat pump to run more as much as possible and really push the limit on that electrification of heat, they can do that too. And then, like I mentioned, with these kinds of installs, thermostats sometimes do need to be upgraded. And that is sometimes not a happy thing to deal with for some homeowners. They like their existing thermostat perhaps, or they have expectations of features. And so not all homeowners were super excited about their new thermostat. The good news is, though, that there are a lot of thermostats out there that can provide basically any feature a homeowner is looking for that work with air source heat pumps in these kind of installations. And so understanding exactly what you like about your thermostat before you make a heat pump change could really improve your experience and help you choose a thermostat that's going to give you the features that you want ahead of time, so that you don't get stuck with whatever the installer happened to recommend or have on hand if your existing thermostat isn't actually compatible. So I mentioned before that a lot of homeowners were satisfied with their heat pump and cited cost as a reason. So we did ask some questions about how they felt about the cost of heat pumps that they installed and whether or not they felt that they saved money. And so what we found was that overall, the vast majority of respondents thought that the heat pump was worth the installation cost, and they thought that the heat pump was saving them money on total heating and cooling costs. One homeowner didn't think that they were saving money, but the reason they thought they weren't saving money was that their comfort was just so much greater. So some homeowners may be willing to pay more in utility bills to achieve extra comfort. And that seemed to be the case for at least one of our respondents. We asked respondents to estimate how much they thought that their utility bills were changing with the heat pump replacement. And overall, homeowners thought that their electrical costs were going up about $42 per month on average based on our responses. And that makes sense. If the system's in a dual fuel situation, you're switching some of your heating from fossil fuel to electric. But simultaneous with that electric utility cost increase, they felt that they were saving money on gas. On average, $90 less on gas per month was perceived. That's a net savings of about $45 a month for these customers. And there were some customers in our pool that did have propane furnaces, and they reported much higher savings from propane displacement. But propane customers in this region don't typically use monthly billing, and so direct month-to-month comparisons are a little bit more difficult to make. So overall, this is promising that homeowners do feel that they are getting cost savings, and that the heat pump is both cost effective on the installation and over time with their utility bills. So that, I want to save time for Kevin to still have some time to talk more details about his system. So that's all I'm going to chat about. I'm going to leave before I hand it over to Kevin with just some big picture takeaways about why heat pumps are a great option for AC replacements. First, they offer heating and cooling all in one system, and they offer you the fuel choice flexibility. You can choose how much you want to use your heat pump versus your furnace, depending on your actual utility rates, which can vary significantly region by region. We definitely had a lot of evidence that homeowners thought that the variable speed heat pump systems were improving the comfort of their home and saving them money on operational costs. Increasingly, there are opportunities for homeowners to access rebates from utilities or state and federal sources to bring down the installation costs of a heat pump. so that they really can help reduce the carbon emissions overall of their heating and cooling system. So thank you for your attention so far. Kevin, I'm going to stop sharing now and hand it back over to you to talk a little bit more about your specific experiences of one system on one home, so we can have a more personal understanding.
All right, thank you very much. Appreciate that. So, I really wanted to take this time to just talk about my experience as a homeowner around the choices I made. So, take you on this little journey and my story. So, February 20th of 2022 is when I chose to make this transition in my home. I live in a city called Oconomowoc, Wisconsin, as represented by the pin on the map. That's about halfway between Milwaukee and Madison, Wisconsin. And so I live in a home that was built in 2005. My existing HVAC system was 17 years old at the time of the replacement, and so now I'm coming up on 18 years. I had no problems with my HVAC. It had regular maintenance and it was in good working order. But I chose to remove the central AC and replace it with a dual fuel heat pump strategy. So this is a representation of the installation I talked about. Earlier, I had shown you why I chose the particular application for this cased coil that works with any brand furnace. I also mentioned to you that I had a comfort issue. You can see the right-hand picture shows my office, where I had chose to put a wall mount unit to maintain comfort and have a separate zone of comfort. And then you can see highlighted in the middle picture is my existing 2005 single speed furnace that's a 92% AFUE furnace with the upgraded cased coil. So the existing, or the old AC coil was removed, and the cased coil dual fuel system was installed. And so my outdoor unit is a cold climate heat pump that is capable of producing 42,000 BTUs of load. I chose this system because it does guarantee 100% of its heat at 5 degrees Fahrenheit. And there's some other performance indicators that, even though that's a rated 42,000 BTU system, in heating, it actually puts out more BTUs, and we'll talk about that more in a second. I wanted to understand how well this product worked. I wanted to push it to its limit, and I wanted to see if I made a choice as a homeowner and try to understand other homeowners that might be in my similar situation. If I choose the objective to maximize the amount of gas I displace, what would be the effects? What would be the results as a homeowner? And so in the controls, I had set my balance point to be negative 11 degrees Fahrenheit, at which I would give control back to the furnace or hand it over, and a furnace delay of 29 minutes. I'm not going to go into exactly how this product is designed to work and operate, but I'm going to talk about the results and the effects of it. So the objectives I was really trying to do was just validate that these heat pumps will do what they say they'll do in the especially extreme cold weather validate how much gas I could displace, understand how, as a homeowner, my energy savings would be affected, plus or minus, and then assess my total energy costs at, with making a decision like maximizing gas displacement. I actually did put a meter, a logger on my gas furnace just to see usage and runtime as part of a study as well. So, if gas displacement was my primary objective, here are the results. So I pulled the latest gas utility bill. I have We Energies as my gas provider in Wisconsin. And I mentioned February 20th of 2022 was the point of install. So the arrow indicates where I saw the impacts of displacing gas within my home, understanding that I still have gas water heater and gas cooking and a gas fireplace. So the top chart shows the amount of therms that I have used for the last 2 years. So you can see the impacts of that on my home. And then the bottom chart shows the actual gas costs. You will see, except for maybe some extreme situations, I have generally my bills are below $20 or roughly about $20 per month. I have an alert on to notify me if it gets above $25. Understanding that there may be times of the year that we have extreme temperatures, which force my system, to operate in gas mode. My experience, having 1 full year of use over the winter, was you can see December of last year, that a little higher gas usage. Well, we had that about 36 hours of extreme sub-zero temperatures where the actual temperature went below -11 degrees Fahrenheit and stayed there for quite some time. And so that is where my system switched over seamlessly during the night. So my story was, it was -9 degrees Fahrenheit. I went to bed, the heat pump was still maintaining the temperature, but somewhere during the night, the controls handed it over to the furnace because I selected -11 degrees Fahrenheit, which is the lowest temperature I was allowed to set the controls to. So I think everybody wants to know what kind of results I maybe experienced. So I have a full year of data listed in 2021 and 2022 operational year. So I'm taking data from March of 2021 through February of 2022, which is the first column. And then 1 year post operation, which is that March of 2022 through February of 2023. And I do have, all the data for, this current year, but it's not 1 full year yet. So I've just shown you what 1 full year of data is at this point. So you can see I had a reduction of my gas usage was about 885 therms. My electric usage went up 3,800 kWh over that year. But what is really interesting, and this all correlates, if you understand COP, this correlates to how efficient these heat pumps can be. So the input energy into my house, which effectively was taking all the gas usage in therms and converting them to kWh. So I did a conversion. My total energy to operate my home prior to the heat pump installation was about 45,600 kWh of energy to live my life operated. Post heat pump was 23,540. So a reduction of 22,000 kWh of energy that has been reduced in my home. So that's input energy I never even needed to use. So gas reduction of 80% overall, 92, if we isolate and take out the water heating, cooking, and the gas furnace, or the, gas fireplace, you can see that my overall heating gas reduction was approximately 92%. Now my electric did go up 29%, but if you look at my total input energy reduction for my home, I'm actually down 48% input energy. So that sounds really exciting to most people, but you always need to look at costs and the cost of those fuels. So in terms of operating costs, if we take the same type of data year over year, it's obvious that with my gas reduction, I had a $702 reduction in gas costs. Again, this is just looking at bill analysis. But my electric costs went up $734. So if you look at just total bills added up, my year-over-year change was $32. So that is really kind of what I wanted to know, is how is this going to impact me as a homeowner if gas displacement was my objective? So my cost went up just a little over 1%. But here's the story that you really need to walk away with. So if you look at the average gas rate, I was paying all-in cost per therm of 93 cents a therm in the first year prior to heat pump. Last year, we know nationally gas costs were up extremely high. My average cost was $1.49 per therm, all-in cost. So effectively, I had a almost 60% increase in cost of operating my home with natural gas. And conversely, my electric rate went from an all-in cost of 12.7 cents to 14.2 cents. So essentially, my electric cost went up 11%, a little over 11%. And you got to understand some of that electric rate cost is due to the high gas costs that were used to generate electricity. So those costs get passed along as a cost adjustment on your energy bill. So what's the moral of the story? The moral of the story is you really need to look at results. And your results have to look at cost of wage. So if you take those two sets of data, had I and did all the calculations and operating my home based on the energy usage, had I stuck with natural gas, it would have cost me $803 more last year heating my home with gas. Now, I want to be clear that that is not always going to be the story, because we know natural gas costs are coming back down. But I don't think they're going to come back down to quite the level, maybe, at least for some time, that they were prior to heat pumps. So I want to talk about decision making. When you look at evaluating my home, here is the design load of my home with the system that I chose to put in my home. The design temp is depending on what source you're looking at, it's somewhere between like -3 and -5. So I use -3. This blue line represents the capacity of my existing system, or of the system I installed. And so you can see that according to the design temps, I'm doing pretty well. And that was reflected in the results that I experienced on my energy reduction. It's when I hit some of these anomalies that are below design temp, those random bin hours of the year, that this system was going to need some backup, as represented by the orange triangle and the secondary heat source. So, you obviously need to look at a variety of things. Number one, if I look at what my calculated COP would be at my natural gas costs, and then if I also presented propane here. So this is what EIA data shows as of yesterday. I would need at natural gas higher than 2.27 COP for it to be economical. So I did this because I thought, well, maybe I need to change my set point if I want economics to be the driver this year. In propane, if it was anything above 1.6 COP, it would be cheaper to run the heat pump. The chart here represents this particular model that I installed and what its watt consumption is per the engineering submittal and documentation, and the rated BTUs hours. As you can see, even though it was a 42,000 BTU system, its rated heating capacity is 100% to 5 degrees per the manufacturer. And so the submittals told me it was going to be 100% of 48,000 BTUs at least till 5 degrees. And so this shows the different capacities and then the calculated COP for that unit. So when I take their data and look at this, even at the sub-zero temperatures, it's telling me it's more economically based on current gas prices I'm experiencing today, that I should just keep my set points where they are. But it's not just on its lowest temp, because you really need to understand how many hours, what is the COP and the average COP you're operating at. So the chart to the right shows all the bin hours you're spending at different temperature zones. And you can see COP varies by outdoor temperature. There's more heat in warmer air than in colder air. So the obvious efficiency will change at various bin temperatures. So I just wanted to represent that the amount of hours that are above 5 degrees was about 92% of the bin hours in Madison, which is the closest weather station that accurately reflects where I live. So with that, there's a lot of things to consider when choosing either, your economic balance point for your home. So with that said, I'm going to hand it back over to Brett, and we'll take questions for Sam and myself. Thanks.
Hey, great. Thank you so much, Kevin. Thank you so much, Sam. We're gonna stick around a little bit for some Q&A here and go through some of the questions that have come up, and we probably won't get to them because there's a lot of fantastic questions, so we won't be able to get to them all. Before we get to those questions, I do want to remind everybody that you can rewatch this session anytime. You can share it with a friend or a colleague and catch anything you might have missed, or catch up on it. Post it on social media too, if you want. We love it when people share our sessions. So you can do that by heading over to our YouTube channel in the next couple of days, or you can go there now, click subscribe, and you'll get an instant update when it's ready. For those of you watching this in the future, not right now, but on demand, take your quiz with an 80% passing rate. And if you pass the quiz, you'll receive your continuing ed certificate. For those of you here today and you've been here for the entire session, logged in appropriately on Zoom with the name you want printed on your certificate, take the survey that pops up and you will receive your email certificate from certs@gutenbergcerts.com. Check your spam if you don't see it. And before we get into all those questions coming in, again, we have to say a huge thanks to our board of directors, our volunteers, our executive director, Jose, Reina, and all of our sponsors who support our work, especially our top tier platinum level sponsors, Mitsubishi, Rheem. They have technology that pulls heat right out of the air, heats water, heats your house, your multifamily buildings, single family, multifamily, you name it. Huge thanks to their support and everything that they do. So this is a question for both of you, and I'll start with you, Sam. the question was there any, in your case, renovations, retrofits, weatherization, whatever you want to call it, things that were done to these homes outside of just the one-for-one replacement? And then Kevin, I'll ask you that specific question for your own house too. So I'll start with you, Sam.
Great question, Brett. So for our study, we recruited homeowners who were actively looking for an AC replacement, and that was their, I guess, segue into the program. We did not require them to make any weatherization improvements as part of the project. We did ask them if they knew if any weatherization had happened, and at many homes did say something had happened, whether it was more attic insulation or new windows, but generally none had reported any deep weatherization retrofitting.
And Kevin, did you do any air sealing insulation as part of your upgrade, or was this just a straight?
No, I did not do any weatherization. The only upgrade or change I made to my system was I elected to put in a little more efficient blower motor. It's still a single speed blower motor, but it's just being that it was an older motor, I just thought something that was a little bit more efficient. So, I gained a little bit off of that, but not significant retrofits or anything to my home.
Sure.
One thing that I'd like to add is that if deep weatherization is paired with a heat pump installation, it is very likely, even in cold climates like Illinois, that you could get the heat pump to cover almost entirely, if not all, the heating load. But weatherization investments are generally the most cost-effective improvement homeowners can make.
Great, thank you for adding that point to it, and I assume that would keep the energy bills down too by having the weatherization. The other, there's a lot of questions, and I'm kind of compiling the ones that sort of were asked at the same time and that stood out to me. But let's just, you had mentioned a little bit, Sam, rebates. Let's address this issue. And Kevin, maybe I'll start with you, and Sam, if you've heard anything. Inflation Reduction Act. We've got the tax credits, they're available now, today. And then we've got the rebates, which, depending on what state you're in, are going to be available probably halfway through 2024, maybe 25, maybe never exist for some of you, unfortunately. We're trying. So how does dual fuel fit into the Inflation Reduction Act tax credits and rebates? Will it be funded at all? Do you know anything about that?
I can speak to that specifically. So currently, the way things are written with the federal tax credit, which was effective January 1st, 2023. So it's been almost a year that's been available. The 25C tax credit as part of the Inflation Reduction Act requires CEE to be the defining metric for eligibility. And so CEE
with Sam CEE.
Yes, CEE, yes, different CEE. Yeah, confusion. So, as long as it meets that efficiency requirement, and of course, CEE tax credit eligibility is defined by the North region and the South region of the US. They defined which states must meet different criteria. And so, we can provide more information on that if people want to know. So that's the tax credit. The tax rebate, once states choose to adopt some form of that rebate program, and again, it will likely vary state by state, their efficiency requirements are Energy Star 6.1. And there's two different criteria. Energy Star 6.1, that is a standard heat pump, or cold climate heat pump. But they do not mandate cold climate in the northern climates. It would be a logical solution. But I'll just use my home as an example. right? I could have chose to put in a standard heat pump and say, I just want the gas furnace to handle load, the balance of the load that a standard heat pump doing couldn't achieve it. And so, that's a choice a consumer might make, is what type of heat pump do they want to put a dual fuel retrofit on? How much do they want the heat pump to do? Is essentially a personal decision.
Sam, any thoughts from what you're hearing? I know you've got a special place there in Minnesota. I know here in Michigan, we're still looking at it. January 1, 2025 is what we're sticking to. So for rebates anyway.
Yeah, it's so site specific, and we have so many people on the line from different places that I don't have anything to add.
Yeah.
I can add just one thing to think about. I mean, I think rebates and incentives are really good solutions as an entry point for retrofitting a home. But you also need to look at whether your utility offers some other incentives, right? There's a wide range, right? Some people may have a heat pump rate that will greatly benefit them, and that pays itself year after year after year. It just keeps paying, right? It's a dividend account that just keeps on paying you. So, look for your utility, whether that offers a heat pump rate. What I noticed as I was went back to my rate sheet, and I told this to Sam yesterday, I said, I didn't notice the fine print before said, from the months of November, I have a municipality that does my electric provider. It in fine print says from the months of November through April, I pay no sales tax. So essentially, I get a roughly 5% credit for electric heating. They're not calling it that, but they're giving me a tax break during those months.
Yeah, I know just from a Michigan perspective, on one side of the state, our biggest utility does have some sort of heat pump rate. And I know we just passed a climate law that is allowing for fuel switching funding. So before, you couldn't get paid to switch over from, methane or propane gas to electric. So so I hope those things are moving forward in other states. Some are further along and some are behind, but yeah, good point. Thanks for bringing up the utility concept. So I think a simple question for you, Sam, would you share at some point the study? How can people access it and review their own copy of it?
So our study was funded by ComEd's Emerging Technology Program, and so they will have information on their website when available with more details on all of the results. And what I shared here is kind of just some high-level conclusions. So there'll be lots of interesting things to look forward there.
So go to ComEd. Do you have any idea when it'll be available?
Next year.
Next year. Okay. Well, that's sooner than later. So, and so the other question was utility bills. Sam, you talked about perceived. So the questions coming in are, were people perceiving they were saving bills, or did you actually get utility data and compare pre and post in your study?
So the data I showed here was perceptions, which are pretty important for how satisfied people are. We did collect data about actual utility consumption. Apples to apples comparisons are a little bit challenging as rates have changed over the course of the study. And we are seeing that homeowners did save money overall on average, but not necessarily a one-to-one for what they perceived.
Yeah. Oh, and I did want to make a clarification because Kevin, I think people can maybe see your mini split. There was a photo of your mini split. So there was some confusion that you were talking only about a ductless system. So just clarifying that you are really talking about you're talking about a hybrid dual fuel ducted system, but then you also have a ductless mini splitter. Am I misunderstanding?
No. So to be clear, I have a multi-zone system.
Right.
So my multi-zone system, a multi-zone system means you can connect multiple different indoor units. The indoor unit could be this cased coil I referred to. It could be a wall mount, which is right above my head, and or any other type of indoor unit configuration. I have my one outdoor unit supplying and providing the heat for both the cased coil and the unit above my head. They are not separate systems. They are one part of one overall system. But you know, the load of my home is primarily served, you know, 2,000 square feet of it are on my fully ducted system that was there already, and I didn't have comfort issues. I had comfort issues in this room, so I chose to eliminate the ductwork or cap off the ductwork feeding this room, and chose to put a separate indoor unit connected to that same outdoor unit. So that's how my system works, but it's effectively
Right.
the ducted scenario is what we were talking about today.
You're right, exactly. It's a little different than in Sam's study, there weren't ductless systems paired in. Now, a question is, does that mini split run along with the gas system, or does it have to be all, you know, the ducted and the ductless system running at the same time, or they both, or it's just the gas system?
No, that's a fantastic question. Very good. That's an excellent question. So the cased coil over my furnace is one or the other. They cannot operate simultaneously on the cased coil. However, it does not disable my wall unit above me from operating. So while the main part of the house might be running off the furnace, this room, I could still operate my wall mount unit to maintain this space. But, you know, because it's a separate zone, I choose to operate it differently, right? I don't need to condition it when I'm not here. So if I choose not to. So, or I can change the different comfort set point. That's the benefit.
Yeah, no, good segue. You know, speaking of set points, Sam, did you in your study, you had mentioned people sort of just anecdotally mentioned set points, but you didn't actually have a way to truly monitor their set points. You're really just taking their feedback. Is that correct?
Right. Yep.
Yeah. Okay. And you know, I'm thinking, and maybe Sam, I'll start with you, but where can we, you know, get into the conversation about, you know, where people are setting the conversion, you know, going from electric to gas, is it typically, where are they being recommended? What temperature is being recommended? And maybe a follow-up question to this is, I think about time of use pricing, or what I just was surprised to learn about was this sort of dynamic pricing in Chicago, where you're getting different prices every minute. I don't know. It's not the hour. It's even more. And I knew, I've heard of those, but I certainly didn't know it came to the Midwest this quickly. So the follow-up question really is, are these systems getting smart enough to where it's looking at the price of gas versus electric and turning it on and off based on that, you know? So answer that question second, because that's getting more complicated, and Kevin will pull you in for that. But the first question is sort of, for the simple approach, where are we setting it?
Great question. So actually, this is sort of still an area of growth for the industry, because choosing this right switchover for a particular home is dependent on a lot of factors. It depends on how big the heat pump is compared to the heat load. There's a limit to how much capacity the heat pump can provide heating, and you definitely you don't want to set it down too low where your house might get cold. You have factors of costs and economics. So for some homeowners, the cost might pan out where it's more cost effective for them to run the gas below 40 degrees, for example. And we did struggle with ensuring, or we saw that not all installers necessarily chose a very appropriate switchover temperature or set up very good controls that made that choice sort of optimized. And so we did make some interventions to reduce or adjust switchovers as needed. And then for some homeowners, there was comfort issues where they did need to push it up a little bit because it was a little bit too chilly for them. But for many cases, we lowered it because we knew that their system likely had the ability to do more. The good thing is that a lot of people are really worried about, does it need to be 17, 18, 25? The specific number is maybe not as critical as people think. Like the difference between a switchover of 30 and 35 can sometimes not make as big of an impact as people think. And especially for anyone who's not especially cost conscious, like I would encourage you to understand what the limit is in terms of comfort, so that you know what you can play with. And if you feel like you want to adjust things based on pricing, you can adjust that. And it would be super great if we got to a point where all the controls were like clever enough to know, oh, gas is this much today and electric is this much tomorrow. And I think like we have the technology to do that. The limitations really are on getting the data. How does your thermostat get that information from your utility company? Do you update it once per year and have to do it manually? Or are utilities going to be willing to generate APIs where software can download the data automatically based on location? I'd love to see that happen. I've been talking to folks about it, and maybe we'll get to that point at some time. We're not there right now. Certainly, it varies a lot depending on location, and different utilities might not have the resources to build that kind of information highway. And so there's going to be some hurdles in getting there that are more practical based in terms of getting the right information. The hurdle isn't that you can't make a software package that could make those decisions if it has the data. The hurdle is getting the data to the thermostat. And so it's not impossible, but it's going to take a lot of folks in the industry working together to make that happen.
Yeah, and I'll throw another wrench into it too. I should have mentioned not just cost, but carbon, right? So you're balancing that set point of comfort, cost, carbon, right? The sort of 3 C's, like where is that perfect level, right? Because maybe you're willing to pay a little more if your carbon's a little less, but in theory, you should be paying less if your carbon's less. So anyway, I don't know, Kevin, just talk about your basic set point levels and then what you're seeing in the industry as far as this sort of dynamic approach.
Yeah, so as I mentioned, my strategy was really understanding what maximizing decarbonization looks like, and I'm talking decarbonization, maximizing gas displacement. So decarbonization at my source, right? At my home. You mentioned, electric generation. That source, I can't control that presently, but I know that, the grid is seeing, generally speaking, an adoption or a rapid movement towards more greening of the grid. So, I know that as time passes and the grid gets cleaner, so does my installation and application. The current controls on my home don't, I have a basically, set it and forget it kind of approach on temperature. And then I told you my furnace cutover set points as well, which were -11 degrees Fahrenheit on my particular system. So I know that we are working on controls over time that we're in development of how do we give consumers more choice for things like time of use rates that could come up, things like capacity balance point versus economic balance point, right? We talked about when is it cheaper to run one versus the other. Oops, it's like let's see if this comes back. Yeah, camera malfunction. Good timing, I guess. So we are working on things that look at economic balance point versus capacity balance point. And then also longer term is how do we take data? It might be more regional in terms of what is the carbon on the grid, basically what are its energy sources for for electric generation, so that consumers might have that visibility to make choices on other inputs. But I think, like Samantha mentioned, there's just gaps in how do you get that information to the controls. But to this point, manufacturers, this is something that eSource brought up a while ago, was, hey, how we need better controls that have this logic and capability, and it's a gap in the market across all manufacturers today.
Well, we are at our time today, so I really appreciate everyone joining us, and Sam and Kevin for your time and talking us through this great conversation. Before we wrap up, and I'll start with you, Sam, I understand the particular study we talked about will be available in 2024 on comment, but CE has a lot of fantastic heat pump resources and other information. So where can people go to contact you or learn more?
You can find us on our website, mnce.org. And my email's here if anyone has a specific question.
Great.
I know there's some other folks in the chat if they have better ideas. We also, for anyone who's in the Midwest, is the Midwest Heat Source or Heat Pump Collaborative. And there's also a Minnesota Air Source Heat Pump Collaborative that has a lot of resources for installers, designers, and homeowners about heat pumps for cold climates.
And Michigan Heat Pump Collaborative trainings are coming your way, so stay tuned, everybody, for whoever's in Michigan. And I'm sure whatever state you're in will have a heat pump collaborative sooner than later. So, and Kevin, where can people go to learn more about the technologies and solutions you used, find out more, contact you if they want to learn more? And quite frankly, I think the big question that came up too was training for contractors, because they certainly probably need to get trained here. So
yes, I think there's a couple resources. Obviously you feel free to contact me, and I'll definitely get you headed in the right direction. But a great resource is just start at mitsubishicomfort.com. And there you can learn about the different types of products and applications and solutions. And if you want to go really technical and find out how these systems work or installed or the engineering data, you can go to mylinkdrive.com, mylinkdrive.com. Every engineering submittal is publicly available for every piece of equipment.
all right, well, we will leave it at that. Again, Sam Hill, CE, Kevin and Master Mitsubishi, thank you so much for your time. Take care, everyone. Be well. We've got one more session next week before we wrap up for the holidays and next year. So we will see you all then. Be well. Thank you so much.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.